everybody. I am Kapil Rajoria, the session chair for session number 43. And this session is on operational excellence, leveraging 4.0 technologies for operational excellence, innovative solutions and best practices. We have three speakers for the day. Mr. Alok Tripathi from BPCL, who will be talking on maximization of isomerization unit value. Pilot that was done in BPCL Kochi refinery. Then we have Mr. B. Sundaramoorthy from CPCL, who will be talking about maximization of Group 1 lube base oil stock production. And the third speaker for the session would be Mr. Chirag Jayswal from Oceaneering International, and he will be talking on subsea robotics. So I invite Mr. Alok Tripathi to please come to the dais and start his session on maximization of isomerization unit value by simultaneously producing food grade hexane and MS motor spirit.
Good morning, everybody. My topic for innovation is unique way of producing food grade hexane in our isomerization unit. Currently, few technologies are available for producing food grade hexane, like adsorptive dearomatization, liquid extraction, naphtha isomerization using divided wall column. All these technologies are cost intensive. So my presentation is how we have co-produced both FGH and isomerate using simple process without any complex column requirement or any mechanical modification of the equipment. So food grade hexane, as you know, is primarily used as a solvent for oil extraction. The source for N-hexane is the naphtha cut from the petroleum fraction. Various grades of hexane are available, like food grade hexane. Food grade hexane, the benzene specification is less than 500 ppm volume. Pharma grade hexane, where benzene specification is less than 3 ppm. So Jan 22, we have co-produced both FGH and MS from our isomerate unit. And the FGH which we have produced has the specification of 50 ppm, which is lesser than most of the technologies which are available as on today. So our Penex unit was commissioned in June 2021, and it uses light naphtha from our NST unit as a feed. So this unit was commissioned with the hydrogen 1:2 reaction, which has a heat integration with NST CCR unit, and it utilizes hot oil system for reboiling instead of steam. So since we are using hot oil, this our operating cost is very less. So before this unit was commissioned, we were making food grade hexane from our existing NST isom unit. So that unit, what it does, it uses steam and uses this recycled gas compressor for circulating hydrogen. So that was driving up the operating cost. So once we commissioned this new unit, MSB Penex unit, the old unit was used exclusively for making FGH. Earlier we were making isomerate also from the same unit. So we contacted our consultant, Messrs. EOP, and our tray vendor, Messrs. Sulzer, to give us a scheme so that we can make FGH from this new unit. So the feedback what we received was FGH can be made from this unit, but we need to do mechanical modification of the column. So it was this time that myself and my team consisting of Sandeep KNS, manager operation, and my process specialist, Mr. Naveen, we decided that we'll identify possibilities of making FGH without making any modification in the existing column. So this is the schematic of our Penex unit. So feed to the Penex unit comes from the upstream from the NST splitter. It's a light naphtha with a distillation range of 30 to 85 degrees Celsius. The feed comes to our de-isopentanizer column, DIP. The top of the column we remove IC5. Balance from bottom, feed goes to isomerization reactor where various reaction happens like benzene saturation and isomerization of NC5 and NC6 to the corresponding isomers. Post isomerization, this product mixture goes to our deisohexanizer column to separate the high and low octane components. So the top components of the DI column, which is basically IC5, 22DMB and 23DMB, they are separated from the top. The bottom contains heavies like NC7 plus. Both these streams are routed to our MS pool. The side stream, which is low octane, unreacted, mainly consisting of 2MP, 3MP and NC6, they are routed back to the reactor for further conversion. So this side stream provides us opportunity to make FGH from this new column. So our DH column was needed to operate in the two mode philosophy. One is motor speed mode, another is food gain mode. So motor speed mode, basically our objective was to maximize NC5, 2MP and 3MP in the side stream. This side stream is recycled back to the reactor to enhance the conversion and to enhance the octane of the isomerate stream. So this mode was basically a recycle mode of operation. In the food head gain mode, basically our objective was to maximize NC6 in the side stream and to avoid any slippage of top and bottom stream, because that would render our product off spec. So basically this mode becomes, in this there is no recycle, so this mode becomes a one-through type of operation. Coming on the methodology, what we have adopted. So what we have done a steady state simulation of our DIH column. So basically at the design feed. So what we found is that for making FGH of the required purity, heavy vapor liquid traffic is required, for which our existing reboiler and condenser duty were not were limiting. So what we did, we carried out the sensitive analysis so to find what could be the maximum DIH feed for which we can get the on-spec product. So what we find is that when the feed to the DIH column is less than 70 tons per hour, my reboiler and condenser duties were limiting. We're at the design limit. And the product also what we were getting was on-spec. So the best option for producing FGH from our column was when there is no side stream to the reactor, no side reboiler, and we need to keep the DIH feed to minimum so that we can have higher N-hexane percentage. So coming on the innovation part, what we have done. So what we did, we reduced the Penex reactor temperature to minimum so as to ensure that benzene saturation is taking place, because we have a spec for benzene in the FGH. And isomerization to be less, because otherwise if isomerization more, then NC6 will not get in our side stream. Then second thing what we did was, we strictly monitored our NST splitter operating conditions to ensure that feed, whatever feed we are getting to our Penex column is having maximum NC6 and lesser heavies. Then our DIH operating conditions, we adjusted our DIH operating condition based on the lab analysis of top, bottom and side streams. The only investment what we have done for this innovation was laying this 10-meter line length, and we utilized our one of the existing facilities to route the product to the storage. This was the only investment we have done in this innovation. This FGH product requires stringent of product specs, like IBP should be more than 63 and recovery should be more than 95. And also the top and bottom temperatures needs to have a very narrow temperature range. So like top temperature, it can vary from 84 to 85, like that it is there. So we implemented APC. So APC helped us to give continuous product on spec product. So you can see once we implemented APC, my DIH column top temperature and side draw temperature, the variation got reduced. Coming on the benefit analysis. So earlier we were making FGH from our old unit. So once this new unit came commissioned, we started making FGH from this. Since old unit was using steam and one recycle gas compressor, this new unit runs on hot oil. So we got a saving around 30 crores per year through this. And also the capacity of our new unit is more. So this enabled us to increase our FGH capacity also. Earlier we were making 1.5 TMT per month. Now we can make, we have the capability to make 4.5 MMTPA, metric ton per month. And that also depends on the market demand. Based on market demand, we'll be making this FGH. And FGH is a specialty product. So it has a premium over naphtha, which is around 10,000 to 12,000 per metric ton. And also over MS, if you see, it ranges from 2,000 to 5,000 over MS. Thank you.
Thank you, Mr. Tripathi. Now I'd like to invite Mr. B. Sundaramoorthy, Chief Manager from Chennai Petroleum Corporation Limited, to make his presentation on maximization of Group 1 lube base oil base stock.
Good morning. Myself Sundaramoorthy, I am from CPCL. I would be presenting a paper on improving value addition through maximization
Mr.
of...
Sundar, can you be a bit louder? I think you're not audible.
Yeah, improving value addition through maximization of lobs. This is the brief agenda of the presentation. I will be covering the brief journey that CPCL and then the LOBS process overview, innovative ideas taken by CPCL team and our R&D initiatives to improve the value addition of lubes, and sharing of best practices that CPCL followed the last 2 years to achieve better production of LOBS. The CPCL journey started with 1969 with a capacity of 2.5 MMTPA with lube oil production from the inception, and gradually the capacity was augmented by addition of a second train of crude during 1984 with adding 2.8 MMTPA capacity, in which we had this FCC and wax added to it. The LOBS and wax are cascading units. The slack wax produced from lube is passing a feed to wax unit. And then 1992 we started producing food grade hexane, and then at 1993 we have done the CBR. We have gone for another plant of 0.5 MMTPA down south Tamil Nadu. Then gradually expanding our capacity by addition of another crude train 3 MMTPA with the state-of-the-art hydrocracker CZR units during 2004. Now at 2017 we have this resid upgradation unit commission full-fledged, and 2019-20 we have implemented all MS and diesel BIS6 projects. Proceeding to future, we have our CBR refinery, Kaveri Basin Refinery. It's a new refinery coming up at Kaveri Asset for a 9 MMTPA capacity, and also a project of Group 2 and Group 3 lobs at Manali. We will be commissioning this unit in 2026. So just to have the overview, we have 3 crude trains and major secondary units in our block, and we will be covering the topic on lube today. Lube oil categories to mention as per API standards, we have three categories of lube oil, Group 1, Group 2 and Group 3. Group 1 base oils are generally categorized based on the saturates in the base oil. The saturate content is less than 90% and the sulfur content is more than 0.03% and the viscosity index ranges from 80 to 100. So basically this base oil is produced in a conventional route from deriving the vacuum gas oils from crude and then further extracted through a classic solvent extraction route and solvent dewaxing route. Group 2 is much more, it's property wise a little similar to Group 1, but however it's very clean and clear. Group 1 base oils are little brown and golden brown in color, but Group 2 is very clear because it undergoes severe hydrotreating, whereas the saturates, if you see, it's more than 90% and the viscosity index also close to 120. Group 3 base oil is further classified from Group 2 case, and it's a severely hydrocracked and hydro-treated, where the VI, the viscosity index is above 120. Coming to Group 1 that CPCL is producing, we have 5 grades of LOBS grades that we are producing. These grades are generally categorized based on the viscosity of the base oil. 9 to 13 CST we call spindle, and second category with 28 to 32 CST we are calling it as light neutral, and 8 to 10 CST at 100 degree we are calling it as interneutral, and final neutral with 10.5 to 12 CST, and bright stock at 29 to 33. The viscosity is a major property for the unit to have the classification, but however viscosity index and pour point are the prime property of lube oil for its performance. So viscosity index is nothing but the temperature behavior of the oil on the viscosity with respect to change in temperature, and pour point is again the property of the oil which ceases to flow, the temperature at which it ceases to flow. CPCL is producing lubes with a pour point of 0 to -6 range, and this is the conventional LOBS production process that CPCL is having. The atmospheric residue from crude units are vacuum distillated, and in the vacuum distillate based on the viscosity the 5 grades are segregated, and then it's stored as vacuum distillates, and further it is getting processed in solvent extraction unit. Here we remove the aromatics. Aromatics are the basic contributor for lower VI. So to improve the viscosity index we use NMP solvent, N-methyl pyrrolidone. This solvent is a very selective solvent towards removal of aromatics, and the final, that is the product coming out of this unit is called raffinate, which is aromatics less but rich in paraffins. So this further undergoes a step called solvent dewaxing, wherein we are using again solvent based conventional process where MEK, methyl ethyl ketone, and toluene are employed in this process to remove the paraffins in the stream. After removing the paraffins, the product coming out of this unit is called dewaxed oil, which is now good in pour point as well as viscosity index. So this undergoes a hydro finishing as a finishing touch to improve its color and stability, and now we have the base oil produced from the block. One more stream which is also getting into this solvent route is propane deasphalting process, where we have the vacuum residue coming out of the crude unit, which is using propane we are removing the asphaltins from the unit, and its asphalt goes for bitumen production. 20% is the yield of the unit, and the residual oil we get from this unit is called deasphalted oil, which again goes through the process of aromatic extraction and solvent dewaxing to form bright stock. One another product which is coming out of solvent dewaxing unit is slack wax, which goes to de-oiling unit to remove the residual oil from wax, and this de-oiled wax is further hydrofinished to produce paraffin wax. CPCL is producing 30 TMT per annum of paraffin wax to end customers and match industry, and LOBS is being produced in the tune of 240 TMT, and it is getting dispatched to Indian Oil. So the production capacity has scaled up in the range of 100 to 120 TMT over the years, and now we have in 2022-23 we have achieved 236 TMT, and now with 23-24 outlook we are targeting 250 TMT of LOBS Group 1 production. The 5 grades that we are producing ranges from tune of 60% heavy grades, which shows our market share that this 250 TMT is very huge in southern market. This LOBS and 30 TMT wax is much higher value added product compared to conventional diesel and MS, and produced from a classic solvent treatment route, and these products are very high in demand and it is domestically sold within India. Now coming to the value addition that CPCL has undergone over these years on improving the production. We have 4 ideas to discuss today. First idea is on enhancing the yield by hydrotreating the loop distillates. Second one on process optimization. Third is co-processing of food soil. And fourth one is quality improvement in dewaxing unit. The first one is on treating the vacuum distillates which are rich in aromatics in a hydrotreating unit. This hydrotreating unit, before BIS6, we had this hydrotreating unit as a post-feed preparation unit for FCC. After implementation of GDS for the BIS6 project, we have this unit as redundant. So we have utilized this unit for treating the distillates for removing aromatics. The stream processed via this unit is IN and 500N. The feed aromatics was in the range of 52 to 58%. Hydrotreating operating conditions were in the range of 55 bar, pressure and temperature of 350 degree. And with the treated rundown, we had the aromatics removed to the tune of 43% in IN grade and 51% in 500N grade. So significant improvement we were able to notice with respect to viscosity index. The delta VA improvement across the unit was 10 to 12 units in case of IN and 12 to 15 units in case of 500N. However, there was a marginal drop in viscosity because of aromatics getting saturated. So this drop in viscosity was made up by fine-tuning the process condition in the upstream unit. So the further processing of this streams in the NMP, solvent extraction unit, we were able to get better yields. On 500N case, we were able to see yield improvement from 42% to 56% to the tune of 13%. And in IN case, we have seen improvement of yield from 62 to 75%. So this value, how it is getting upgraded is, the extract is the byproduct which is coming out of the NMP unit. This extract is normally routed to bitumen or fuel oil, which is having very low value compared to LOBS. And this is how the value is getting upgraded. And the overall LOBS improvement on an annual basis is 15 TMT. Moving to the next point is process optimization in NMP unit. Major steps taken here is all in-house. This feed entry point change, extraction column has 2 feed entry points to the extractor where the solvent and liquid get exchanged across in a counter-current way. We have changed the feed entry point from the bottommost point to the third bed point. We have 4 beds. So by this, the solvent extraction process and the efficiency was improved. Then the second idea was to fine-tune the solvent feed mix ratio. Solvent to feed mix ratio was varied based on the viscosity index of the unit, and then we were able to fine-tune it to the tune of 1.7:2 ratio. And further is the novel one where we added water into the circulating solvent. Solvent is very selective and towards removal of aromatics. We also found that water is, NMP is very soluble readily with water. So injecting water to the tune of 2 to 3% with the circulating solvent, the yield was able to improve to the tune of 5 to 6%. So to summarize, the overall benefit out of this idea was improving the production to the tune of 15 TMT per annum. The third one is on the R&D initiative. This co-processing of food soil in a solvent dewaxing unit. CPCL has in-house R&D facility. We have processed the raffinate streams which are coming out of the NMP unit, and we have analyzed their properties on viscosity and pore point. We found that the food soil which is coming out of the de-oiling unit found to be more comparable with the other streams which are getting processed. If you see, the viscosity index was 105 compared to other raffinate streams which are 98 to 100, and the pore point was 21 against other streams of 30 to 40 range. So food soil recovered from this unit was found suitable in co-processing with raffinate streams for dewaxing unit. So the benefit out of this idea was 10 TMT per annum of LOBS we were able to upgrade. The blending was done on the feed tanks with a mixed ratio of 10%, 5 to 10%. On 10% scale, we were able to get the quality achieved. If you see the table below, we were able to achieve the viscosity index of 95 specification, we were able to get 98, 95 and 100 comparable with other operation. Also 4 point of -3 we were able to achieve. The last point is on the quality improvement in solvent dewaxing unit. We have this hydrocracker with CPCL operating at 60% conversion. So the remaining 40% of oil is called unconverted oil. This unconverted oil was tested in our R&D and found to have 90 to 95% saturates. So we have done an in-house study to co-process this UCO in our solvent dewaxing unit. So solvent dewaxing unit, while processing several crudes, we have constraints while processing opportunity crudes. So the VA gets dropped during this process. So in order to improve the VA beyond 90 to 95, we have done this UCO co-processing. The co-processing was done with a 10% scale in paraffin, the solvent dewaxing unit, and then we were able to extract this oil along with the dewaxed oil. The trial run was conducted successfully, and the final product was able to meet the LNHVA specification readily with an improved viscosity index of above 100, though the specification is 95. So with which I complete the ideas that we have CPCL has taken to improve. And the next step to proceed on future scale, CPCL is going to implement a Group 2, Group 3 projects in Manali campus in Chennai. This will be a revamp of our hydrocracker unit. Hydrocracker is processing a VGO from straight run product from crude units, as well as heavy hooker gas oil from DCU. Presently, these two feed streams are processed in our hydrocracker with a conversion of 60% and producing middle distillates, SK diesel, and post installation of a catalytic dewaxing unit into the campus, we will have a production of 270 TMT per annum of Group 2 and Group 3. So this project is expected to complete by 2026, and CPCL will be able to improve the scale of LOBS from present level of 2.5% on crude mix to 5%. Thank you for patient listening. I thank my CPCL management for representing, for allowing me to give this paper to this forum. Also, I have a co-author with me from technical department, Mr. Reddy Prakash. So I thank him also for enabling me to present his case on behalf of him. Thank you. Thank you.
Thank you, Mr. Sundaramoorthy. Now may I invite Mr. Chirag Jayswal from Oceaneering International to make his presentation on subsea robotics for operations and maintenance of late life subsea assets. Mr. Chirag Jayswal.
Thank you, Rajoria sir. Okay, so before I get started, let me thank a few people. Right. First of all, Rajoria sir, thank you for chairing the session. My co-speakers, the technical experts on downstream side, Alok and Sundar, was lovely hearing you. And my colleagues and everybody else who is here to cheer me up today. Thank you. I'm Chirag. I come from Oceaneering. I'm working as an engagement head with the India Technology Center. And I'm so happy to talk to you about a solution, Emerge, IMRGE, which helps do inspection, maintenance, repair in much more efficient way using some of the advanced technologies using subsea robotics. So before we know more about IMRG Emerge, let me give you a quick overview about what Oceaneering is in general. Oceaneering has got these 5 business segments, as you can see on the screen, starting with subsea robotics, remotely operated vehicles known as ROVs, underwater autonomous vehicles known as AUVs. We are the market leaders and pioneers when it comes to subsea robotics. Second one is offshore projects group, vessel integrated projects, IMR solutions, flow control solutions, and engineered solutions. Right? If you need anything, offshore projects group, that's the way to go. We have got integrity management and digital solution arm as well, with a very clear focus on enhancing the reliability and efficiency of assets operating in entire oil and gas industry as well as other industries. Manufactured products that works on manufacturing and delivering some of the important assets for oil and gas industry like umbilical and associated hardware. We also have aerospace and defense technologies, which works on marine defense and aerospace projects. That's about Oceaneering. Our solution Emerge has required us to use technologies available across the different business segments and be able to have an integrated approach to improve efficiency of how we carry out IMR. Right, so before we get into solution details, you might have questions to why IMR in the very first place. IMR stands for inspection, maintenance, and repair. This roughly consists about 20 to 50% of operational expenses for offshore asset. It's a huge amount of spending. Second thing, IMR is unavoidable and one of the most important element to ensure the reliability of assets. So any improvement in the way you carry out IMR, anything that you can do in terms of increasing the speed of IMR, reducing the cost of IMR is more than welcome. Many of our clients did challenge us that, hey, can you carry out inspection in some of the subsea complex environments? And in addition, can you also help us reduce the carbon footprint by number of vessel days being reduced or number of people on board reduced? And say, why not? Let's get it up, right? So that's how the idea for Emerge came in. So Emerge leverages some of the most advanced technologies on inspection today and state-of-the-art software to improve overall efficiency in the entire stage of inspection, maintenance, and repair. Now, before it gets too boring, let me use a video for you to just see through as to what these elements of IMR are all about. I would give you a running commentary when you play the video. So it's an integrated approach through which the operators don't have to deal with multiple contracts at the very first place to carry out inspection, maintenance, and repair. It's very well integrated solution. It starts with creating a baseline using the client supply data of operations and inspection that we can load to our cloud. A team of experts uses RBA, risk-based assessment, RBI, risk-based inspection software that we call Inform to create inspection and maintenance plans that we subsequently pass on to our operation teams. Our vessel integrated projects group works on delivering IMR execution scopes end to end. You can see an ROV carrying out inspection of a marine asset using UWILE, underwater inspection of dry docking, in light of dry docking. This eliminates the need of having any asset dry dock, reducing the number of days that it requires to get inspection, and it doesn't have to go out of the production at all. It's a huge advantage when it comes to carrying out inspection. Here we deploy Liberty, our resident ROV system. It resides subsea. It has got a cage. It assists in carrying out inspection of subsea assets, including structures. It does its job, and it comes back in the cage to get recharged and goes back again to carry out its job. It improves efficiency significantly in the way we carry out inspection. Here, one of our Freedom ROVs deployed to carry out pipeline inspection, as you can see on the screen. Freedom can be pre-programmed to follow a stream path or can also be piloted via tether. Now, Freedom can carry out inspection, not just that. If it detects the leak, it can go down and can carry out more detailed inspection of that area on its own. This helps the operator, inspector to get more visual details and see as if there's any problem with the asset or not. The same Freedom can carry out inspection of mooring chains in a wind farm over here, subsequently followed by our work class ROVs doing cleaning and further detailed inspection work. Our ROVs can also be lensed with photogrammetry capabilities through which we can create detailed 3D models of any asset subsea in as-is condition. And this really helps the team of experts, operators, inspectors to decide whether there's any issue with any of the asset or not. And how is the asset behaving over the period of time. Our operators can see all the data of inspection 24/7 as well whenever they require. If we see any issue by any chance on any of our asset, we can instantly engage our engineered solutions team as well. An engineered solutions team works on designing engineering solutions catering to any problem that we have encountered subsea for any of the asset. A project group then can subsequently help deploy such solutions. You can see some of the solutions over here catering to well flow control as well as pipeline repairs in action. Oceaneering is the only company that takes up end-to-end work when it comes to things like pipeline and other subsea asset integrity management as well. So in process, we touch inspection, maintenance, repair, the entire life cycle, reducing the time taken to carry out each of the thing, improves efficiency, and most importantly, it is done in an integrated way, and requiring operator to deal with only one particular contractor over here. It's important to note over here that many times when the inspection is carried out, you require a second vessel to carry out maintenance and repair as well. Now, in this case, while a world-class ROV carries out maintenance and repair, a Freedom ROV that is all autonomous can carry on with the swim path and does inspection on its own. So you do two jobs in price of one vessel, which is significant saving when it comes to how you carry out IMR. This is the value that we deliver through the solution that we just talked about. We use many advanced technologies to carry out inspection in more efficiency. We use touchless methods as well to measure things accurately for subsea assets. The solution reduces the number of days that a vessel is required for. At the same time, because we use our offshore remote operation center wherein our operator can see through things without really having the need of going on an offshore asset, it minimizes the need of people on board. And all this helps reduce the carbon footprint you are leaving behind through your operations. This is where it gets really exciting because it has some quantifiable numbers. So through use of things like UWILE, the inspection cost goes down to almost 50%. Some of our clients have really liked this a lot. At the same time, through Freedom ROV, it helps you reduce the vessel days required by about 45%. And OROC, Offshore Remote Operation Center, helps reduce the number of people required by almost 33%. And most importantly, touchless methods for carrying out measurements gives you very accurate data with minimal risk, and over a period of time, it helps you make more and more efficient decisions for your IMR related things. So that's about the IMR solutions. I'm sure you might have questions. Get in touch with me or any of my team later. We'll be more than happy to help you solve some of your complex problems in the subsea industry. Thank you.
Thank you, Mr. Jayswal. So we have had 3 interesting presentations. Mr. Tripathi talked about the innovative methodologies that were used in the isomerization unit and which led to an increase in production from 1500 metric tons to 4500 metric tons. And for a product which is a specialty product and which has got a higher value as compared to naphtha. Then Mr. Sundaramoorthy talked about the increase in value in the LOPS plant by using 4 innovative ideas and the increase in yield, quantifiable yield that emanated out of implementation of each idea. Then interesting presentation by Mr. Chirag Jayswal on the IMR and what all is being done or what are the possibilities with the solutions that are provided by Oceaneering International using robotics for subsea assets, and how these methodologies deliver value in terms of quantifiable savings and reduction in carbon footprints. So thank you, gentlemen.